Good evening, everyone. Tonight we're going to be talking about triangle congruence.
Congruent figures are the same size. They have the same shape and the same corresponding angles and corresponding sides. So corresponding parts are in the same position on the two figures. So for example, these two triangles below, this angle and this angle would be corresponding. They're congruent and at the same position in the triangle. And then here, this side and this side are corresponding because they are congruent and they are on the same portion of the triangle. With congruent triangles, we have the congruency statement. It's a statement that says two figures are congruent, and the order is very important whenever you talk about the congruency statement. So here I have triangle ABC. Well, we want the letters to go in the same order so the corresponding parts match. So then ABC would be congruent to FED because I went from the 1 mark angle to the 2 mark angle to the 3 mark angle. So over here is my congruency statement. Triangle ABC is congruent to triangle FED. I could also go in another order and say BAC would be congruent to, I'm also going to have to change the second order to triangle EFD. But it's very important so that the first letter of each triangle are the two congruent angles. And then the middle letter, same thing, those two would be congruent, and the last letters C and D, those would be congruent. We can also talk about their angles, so A congruent to F, B congruent to E. Again, if you look in your congruency statement, B and E are both the first letter in each triangle, so then B would be congruent to E. And then for the sides, AB is congruent to FE, and BC is congruent to ED. Alright, now we're going to write the congruency statements for all the corresponding parts of these two triangles. So the first thing I'm going to do is write my triangle congruency statement. So I'm going to want to match my letters up. So I can say triangle KJL, so I went from 1 mark, 2 mark, 3 mark. So then I would have to say is congruent to triangle STR, 1 mark, 2 mark, 3 mark. So I write my congruency statement, triangle KJL is congruent to triangle STR, and then I also can write 3 congruency statements for each of the 3 angles, and then 3 congruency statements for each of the 3 sides. So we have to match up my congruent angles. So angle K and angle S both have a 1 mark, and so they are congruent to each other. Then J is congruent to T, and angle L is congruent to angle R. And then last, we have our 3 sides. So KJ is congruent to ST. They both have the single tick mark. And then JL is congruent to TR, and LK is congruent to RS. Next up, we have the third angle theorem. The third angle theorem says that if 2 angles in one triangle are congruent to 2 angles in another triangle, then the third angles are also congruent. So here in the picture, we have 2 triangles. And in black, this is the information we knew before. We know angle A is congruent to angle D, and then angle B is congruent to angle E. So if we know those 2 things, then we know that angle C and angle F have to be congruent to each other. This is because we know there are 180 degrees in a triangle, and if we've already spent the same amount of degrees on A and B as D and E, then they would both have the same leftover from the 180 that has to be angle C and angle F. Now we're going to have a look at this problem. They want us to find the measure of angle BDC. So that's this large angle right here. So in this picture, I have 2 triangles stacked on top of each other, so sometimes it's easier to redraw the second triangle below or to the side so that you're looking at them separately. So here I have highlighted triangle ADC because that's the one I'm going to focus on in the original picture, and then I've redrawn triangle BCD down here. Well, if you look in the picture, here angle A has a 1 mark just like angle B. So angle A and angle B are congruent to each other. And then angle C has 3 congruency marks just like angle ADC. So that means those 2 angles are congruent. So angle B is 45 and angle C is 30. So now we can say that since angle A is congruent to angle B and angle BCD is congruent to angle ADC, then by the third angle theorem, then we know that angle ACD is congruent to angle BDC. And since these create a triangle, then we know all we have to do is subtract the angles we already have from 180. So the measure of angle ACD is going to be 180 minus 45 minus 30, because those are the 2-degree measures that we already have in our triangle. So that means that the measure of angle ACD equals 105 degrees, but that's not what they asked us for. They asked us for BDC, but because we knew about that third angle theorem, we know that those are going to be the same. So the measure of angle BDC equals 105 degrees. And that's everything I have for you this evening. See you in class.